This is chapter 5, part 2 to the videos, and in this video I'll go through examples of finding derivatives and integrals involving the exponential function. All right, so I wrote down in green the derivative rule for the exponential function involving e. So the derivative of e to the u is equal to itself, e to the u times u prime. So you take the derivative, u prime is the derivative of whatever the portion function is in the exponent. And then integrating e to the u also becomes e to the u. And then plus your constant of integration. So I have these 4 examples where I'll find the derivative, and then these 4 examples where I'll integrate. So derivative examples. And the rule we're using in so the exponential e, its derivative is the same thing, e to the u, but then times by chain rule the derivative of whatever is in the exponent. Okay, that's just way it's defined, and then when you integrate it, it also becomes e to the u. So it's y equals e to the 5x. So our exponential portion is 5x. So like u is equal to 5x. So then derivative u prime is going to be 5, because that's 5 times 1. The root of x is 1. So y prime, that's equal e to the 5x times u prime. Well, u prime is 5, so it'll be times 5. So the derivative is 5e to the 5x. All right, so that's it for that one. Number 2 is f of x equals 4 times e to the x squared. So I'm going to focus on taking the derivative of e to the x squared, because you'd factor out the constant. So like f prime of x is going to equal 4 times d dx of e to the x squared. And my u in this case is x squared. The derivative of x squared is 2x, so u prime is 2x. So this is going to equal 4 times e to the x squared times the derivative of x squared, which is 2x. So then I do 4 times 2 to get 8, and just put x in front of the e, so it'd be f prime of x is equal to 8x e to the x squared. Again, we just keep using that same rule. Where's derivative of e to the u? It's e to the u times u prime. It's just our u portion is x squared. So derivative of x squared is 2x, and then I factored out the 4 in front and focused on taking the derivative of e to the x squared. Number 3 is 7e to the 2 times sine x. All right, so again, the constant 7 I factored out. So it's going to be 7 times the derivative of e to the 2 times sine x. u is the exponent portion, 2 times sine x. And recall that the derivative of sine is cosine. So u prime is 2 cosine x. So applying our rule, so this is going to equal 7 times. So we have our regular exponential e to the 2 sine x, that's our e to the u. And then times the derivative of 2 sine x, that's the u prime, which is 2 cosine x. All right, that's our u prime. So I do 7 times 2 is 14, and I'll reorder it, so it goes cosine x before the e. Generally like putting the e portion last. So it'd be 14 cosine x e to the 2 sine x. All right, and then the fourth one is g of x equal to x plus 1 squared, and then e to the x. All right, and I have a product, so we're using the product rule for the derivative. Because I have x the plus 1 squared. You could expand that out. I'm going to leave it as is. But the product rule, you have u times v is the derivative of the first function times the second, plus the first function times the derivative of the second. And in this case, u is going to be the x plus 1 squared. And then v is the e to the x. So we have to find u prime. So u prime is the derivative of x plus 1 squared. And that's going to use the general power rule. So let me write that down. It's really just a chain rule. So that's n times u to the n minus 1 times u prime. And in this case, my u can be considered the x plus 1. So the derivative of x plus 1 is 1. So u prime, for this part in green, that's going to be equal to, so by the general power rule, I drop down the 2. So that's 2 times, and then x plus 1. 2 minus 1 times the derivative of the inside function, which is x plus 1. Derivative of x is 1, and the plus 1 goes away because that's a constant. So technically, you could write it as times 1. So u prime is 2 times parentheses x plus 1. V, well, the derivative of e to the x is the same thing, e to the x. All right, because of the rule, derivative of e to the u is e to the u times u prime. it's just u is x, derivative of x is 1. So it will be e to the x times 1, which is e to the x. Okay, so I'm going to plug these into the product rule. And so I'll use the colors you see. So g prime of x, that's going to equal u prime times v. U prime is this, 2 times x plus 1. And then v and v prime are the same. They're both e to the x, so that's nice. So it's going to be e to the x. All right, that's the u prime times v, then plus u times v prime. U is x plus 1 squared, and then v prime is the same as v, it's e to the x. All right, and now I just try to simplify this. Now both terms contain x plus 1 and e to the x, so I'm going to factor out e to the x times x plus 1. And factoring that out from the first term, that basically gets rid of these, so I just have 2 plus, and then this one, the second term, I got rid of e to the x, dividing that out, and I'm dividing out one of the x plus 1s from x plus 1 squared, so that just gives me just x plus 1. All right, so then keep simplifying, so g prime of x, that's e to the x times x plus 1, and then I can add 2 with 1 to get 3, so it'll be x plus 3. And then this is the answer, it's in its factored format. Again, so this was u prime, this was v, this was u, and this was v prime. And then I factored out the common thing that they had was x plus 1 and then e to the x. I just listed the e to the x first. And once I factor that out from the first term, it just gives me 2. And factoring it out from the second term, x plus 1. All right, so now the integration examples. And recall the rule for the integrating e to the u just becomes e to the u, and it just matters what you use for u. So number 1, you're integrating 5e to the 5x dx. So the u portion is just going to be 5x. And then normally I'd factor out the 5, but you'll see why I don't, because when I take the derivative, du is going to be equal to 5 dx. So I already have that in the integral. So I could write it like e to the 5x times 5 dx. And then based on our rule, so this is like e to the u. And then du is 5 dx. So that becomes e to the u plus c. And then I back substitute. Well, u was 5x. So it's e to the 5x plus c. All right, so that's it for that one. The next one's 3x e to the x squared. All right, here I will factor the 3 in front. So the integral, and then I'll put e to the x squared and then x dx. Because I'm going to let u be the exponent portion, x squared, and the derivative of x squared is 2x. And here we have x, though we're going to do some manipulation. So I'll use a different color. So I'll let u be x squared. So du is 2x dx. I have x dx, so I need to divide by 2 or multiply by a half. So I have 1/2 du equal to x dx. All right, so this x dx part is the 1/2 du. And the x squared is u. So substituting that in, so we have e to the u, and then x dx is 1/2 du. Now I'd factor out the 1/2. So then you have 3 times a half is 3 halves. So now you're left with e to the u and then du, which we know becomes e to the u because that's the way the function's designed. So when you integrate it, it turns back into itself. So it's going to be 3 halves e to the u plus c, and then I just back substitute u as x squared. So that's 3 halves e to the x squared plus c. Okay, so that's that one. The next one is e to the square root of x divided by square root of x, and then dx. So the pattern is we always let u be whatever the exponent portion is of e x squared, or x to the square root of x. And we know the square root of x is x to the 1/2. So I'm going to first write it as e to the x to the 1/2. And then I have divided by x to the 1/2. And then dx. Well, since I have x to the 1/2 in the denominator, I can bring that up to the numerator by making that a negative exponent. So I have ex to the 1/2 times x to the negative 1/2, and then dx. That way, when I substitute for u, because u is going to be the exponent portion for the exponential, so u is x to the 1/2. So du, that's use the power rule for derivative, so it's going to be 1/2 x to the 1/2 minus 1, and dx, so that's 1/2 x to the negative 1/2 dx. So I have the x to the negative 1/2 dx, but I'm missing the 1/2, so I need to get rid of the 1/2 by multiplying both sides by 2. So on the left side, you get 2 du, and the 2 cancels out with the 1/2 to get x to the negative 1/2 du. All right, so this is 2 du, and we know the x to the 1/2, that part is u. So that's going to be the integral e to the u, and then 2 du. So now it's a lot easier. I'm going to factor out the 2. And we know integrating e to the u becomes e to the u. So that's 2 e to the u plus c. And then I back substitute what u was. U was x to the 1/2. And then I would write anything to the 1/2 as the square root. So it's 2 e to the square root of x plus c. Again, so I rewrote it so that when I'm doing these substitutions, recall that the last stuff I was doing in chapter 4 is u substitution. That's what I've been doing for these integrals. I let u be the exponent portion, and we started out with e to the square root of x, which the square root of x is the same thing as x to the 1/2. So I just went ahead and wrote it as x to the 1/2. Because x to the 1/2 is also in the denominator, I brought that up to the numerator, which by exponent rules makes that x to the negative 1/2. So when I let u be x to the 1/2, du is 1/2 x to the negative 1/2 dx. And so I have the x to the negative 1/2 dx in the integral. I just don't have the 1/2, so I multiplied both sides by 2, so that I have 2 du is equal to x to the negative 1/2 dx. So I can substitute 2 du in for that into the integral. And that's what I did here. And then just integrated using what we know when you integrate e to the u, it becomes itself e to the u. All right, so the last problem for this video is integrating 2e to the sine x cosine x. So I'll factor out the 2. That's 2 times integral of e to the sine x. And then I have cosine x dx. So like before, I just let u be the exponent, and the exponent sine, so u is sine x. And then du is going to be the derivative of sine is cosine, so that's cosine x dx. And that's what we have already in the integral. So this whole thing is du, and the exponent is u. So just substituting it in, it's 2 e to the u du. And we know integrating e to the u is itself e to the u. So that's 2 e to the u plus c. And then I plug in u as sine x. So this is 2 e to the sine x plus c. All right, and this was the second part to the chapter 5 videos, and this dealt with integrating and finding derivatives involving the exponential. Next video is going to be dealing with integrating and finding derivatives involving the natural logarithm.